Okay, so the goal for this problem is to verify that we have two given solutions. Keep in mind this does not mean to solve the equation, so we're not going to be solving it. Instead, we're going to show the solutions make the differential equation true. So let's start off with y1. For starters, we need to make sure we go in and we calculate the first and second derivative to verify this. So first derivative, pretty easy. It's just going to be 4 times e to the 4t. And then for the second derivative, y1 double prime, that's going to be just 4 times 4, which is 16 e to the 4t. Now to do the verification, we start with the actual differential equation, which again is y double prime minus 8y prime plus 16y, and we're plugging in, or substituting in, y1. So upon substitution, we're going to have the original y double prime, which we just found, which was 16 e to the 4t. And then the differential equation has a minus 8 in it. And then that's times the y prime, which is above e to the 4t times 4. And then we have plus 16 times that function y1, which again is e to the 4t. It's pretty obvious now that if we take 16 of something minus 32 of something plus 16 more of the same thing, we of course get 0. So y1 is easy to see that it checks out and works. Now let's move on to y2 and do the same thing. So for y2, we're going to first take our derivative, and you will notice for this function here, we need to use the product rule. So derivative of the first is 1 times the second, e to the 4t, plus first times derivative of the second. And it's always a good idea to simplify these down before going further. So that's going to be a 4t plus 1 times e to the 4 times t. Now let's go in and find y double prime of t for the second function. Derivative of the first, 4t, of course, is going to be just 4 times the second plus first, 4t plus 1 times the derivative of the second, 4 times e to the 4t. We once again cleaned this up. Keep in mind this time around that we've got the 4 multiplied to both terms in here. So our first term is going to be a 16t. Then we've got a 4 from this and this 4 here, adding together to make plus 8 e to the 4t. Once again, we substitute into the original differential equation. And when we substitute in, we're going to have the y double prime we just found, which was the 16t plus 8 e to the 4t. Then we've got minus 8 times our first derivative, which is 4t plus 1 e to the 4t. And then plus 16 times the y2 function, which is again t e to the 4t. And again, we don't know it's equal to 0, but we are hoping that it will work out to be equal to 0. Multiplying out, we've got a 16t plus 8 minus a 32t minus an 8 plus a 16t, all times an e to the 4t. And we can easily then see that 16t plus another 16t minus 32t cancels out. Positive 8 minus 8 cancels out. So this also makes 0. So we've shown that both of those functions, y1 of t and y2 of t, make our differential equation true. So the verification is complete.